Welcome to 1-3's video, and the lesson essential question is, how can I write equations for lines which are perpendicular, parallel, horizontal, and vertical? So as we're learning today, keep in mind the answers for these things. So, as you learned from the investigation class, parallel lines have the same slope. So this is my equation for writing a line where I have a known point going in for y1 and x1. And the known point here is 4, -2, where x is 4 and y is -2. And the slope being parallel, the slope is the same. So I'm just going to take this shell and I'm going to put a new number in for y1, for m, and for x1. So it would be y minus the y value of -2, which would be -2, equals slope of 4 over 3 times x minus 4. And then I'm going to change this to y plus 2, because a minus and negative is a plus, equals 4 over 3 times x minus 4. And that is the answer. This line goes through the point 4, -2. I can know that because it has 4 in for the x1 and -2 in for the y1, and the slope is the same. The more difficult thing is with perpendicular lines. So in the video, or in the class, we learned that perpendicular slopes have the negative inverse. So I'm going to take the line here. So line J and K are perpendicular. This is the slope for the line J. What's the slope for K? So I'm going to take my fraction and I'm going to write it like this. I'm going to take the 2 and I'm going to move it to the bottom, the denominator. And I'm going to take the 3 and I'll move it to the numerator. So I'm going to get 3 over 2. But it's the negative inverse, so I'm going to make it -3 over 2. For B, it's already negative, and it's a -4 over 5. So I'm going to take the 4 and move it to the denominator, the 5 and move it to the numerator, and I'm going to make the negative sign go away. If I add another negative sign, it cancels out. So that's the answer for B. So I want you to pause the video now, and you guys try number 3. Okay, so there is no bottom number, but we should know that any number can be divided by 1 and it won't change the value. So now I have -3 over 1. I swap the numerator and denominator, get 1/3, and then it is negative already, so the negative inverse just makes it 1/3. Here's a problem that's not in the book that I wanted to go into. So we're now going to use these slopes to make an equation for each line that goes through the point 3, -2. So if I remember from the previous slide, I need the equation y minus y1 equals m times x minus x1. So for A, I'm going to have y minus -2 equals slope. The slope that's perpendicular to 2/3 is the negative inverse of -2/3. I'm sorry, -3/2 times x minus 3. For B, it's going to be the same thing. Y minus -2 equals the slope times x minus 3. And the slope would be 5 over 4. And then for C, the same thing. Y minus -2 equals the slope of 1/3 times x minus 3. So to do these problems, I take the negative inverse if it says perpendicular, and then I write the point-slope equation right here. I'm going to be given a point. I put that in for x1, y1, and I take the negative inverse and I put it in for my slope here. So this is going to be one that you guys are going to try. I'm going to help you out first, though, because this equation is not in point-slope form. Usually it was y equals mx plus b, where m is the slope. So I'm going to take the 2x, I'm going to subtract 2x from both sides. So now it's y equals -2x minus 7. So now it's in y-intercept form, and I can find the slope. So pause the video and try the answer. Okay, welcome back. So hopefully I realized that the slope is -2, and a perpendicular slope would mean I have a -2/1, and that's going to become a 1/2 negative inverse. So I look at these two problems, and I can automatically say it's not A and not B. This is the same slope. Well, this is a parallel line. This is not anything. Now that I have the slopes right, I'm going to look and see, oh, the only difference is it's a negative and a positive 2. So the point here, it would be y minus -3, so that y plus 3, that's correct on the left side, equals 1/2, we figured that out, and then x minus, it's always x minus 2. So the right answer was D. Give yourself a high five if you got that right. The next thing is, how do I do horizontal and vertical lines? The slope is easy to find, but difficult. So consider the 3 lines you drew for question 1, which looks like this. For any horizontal line, when x increases by 1 unit, how many units does the y change? So let's just do that here. If I have k and L, and x is going, so x was going from 4 to 12, so I can do 4 minus 12, and the y value was 12 minus 12, and that gives me a 0 over a -8. And anything divided by 0 is 0. So a horizontal line is a 0 slope. Now we're looking at the vertical line. So I'm looking at point K and point G. So I'm going to use this. The x value goes from 4 for G, and it stays 4 for K. So that's going to be 4 minus 4. And the y value goes from -4 for G and 12 for K. So I'm going to have 4 minus 12. So now I have a -8 over 0. And this is very bad. You can't divide by 0. Oh no. So this one, vertical lines, have no slope. And vertical lines and perpendicular lines are perpendicular. Vertical lines and horizontal lines are perpendicular. So if I had 0 and -8, and I wanted to make the negative inverse, it would be 8 over 0. And if I look back here, it is, 0 over 8. So I would be taking, I'm sorry, that was messed up. It would be 0 over -8, sorry. And I look back here, and it is 0 over -8. But this one is 0, and I can't divide by 0, so the vertical line is horizontal. Okay, equations for horizontal and vertical lines. We are not going to use this. It won't look like this. For horizontal lines, the slope is 0. So if I pick this point here, K, K is 4, 12. I can do y minus 12 equals, we know the slope is 0, times x minus 4. Well, 0 times anything is 0, so now I'm left with y minus 12 equals 0. And I can change that to y equals 12. And then if I look here, and I just make this line go farther, it goes through the y-axis at 12. So for horizontal lines, it's a y equals whatever the number is that it goes through the y-axis. For a vertical line, well, if I wanted to do this, I would have y minus y1, which would be 4 or 12, times equals an undefined slope times x minus 4. So that doesn't work. It's going to be the same principle as with the y-axis. The x line goes through 4. So a vertical line would be x equals 4. Or in this case, if I draw this one here, x equals 16. So the key takeaways from how to do vertical and horizontal lines is that horizontal lines are always y equals the number of the y-intercept. And vertical lines are always equal to the x equals a number, and that number being the x-intercept. So that is the end of this video, reviewing of what the lesson essential question is. How can I write equations for lines which are perpendicular, parallel, horizontal, and vertical? So I answered all that stuff. There's going to be a question right now for you to type it in to see if you can recall that stuff. Before you can answer this verbally to me, you should do the Delta Math, which is 1-3, and then do 2 lessons of Mathia, and that's going to reinforce the answer for this.